Hey y'all, it's Anirudh one last time. This time we're going to be going over midterm 1, question 7, part C. This question is a little bit more challenging than the others because, well, there's a lot more going on and we need to debug a little bit actually this question to figure out the right way to approach it. So let's go ahead and get started. It says here that we have a container list class with the drain first method, but the drain first method sometimes errors. Okay. Well, it looks like we can add code to the container list constructor and the unknown container class, but we may not modify the drain first method. So we can't fix the problem. We just have to figure out how to make sure the problem is dealt with. Okay. You may use 5 lines of code in the container list and add 4 lines to the unknown container class. All right. If you keep or modify the given line, it's one of the 5. And the drain first should never error and retain the functionality, even if called many times. Okay, so that was a lot of stuff. And when it comes to this question, there's a lot of ways that you can approach it, right? There's, I think, 3 big things that are going on. The very first one is that you have to figure out what this unknown container class is and what you need to add to it, if anything. Then you need to figure out what's going on, or not then, you also need to figure out what's going on inside this constructor for container list. You also have to figure out what's going on with the drain first and why exactly this is going wrong. So let's start with figuring out what's going wrong and diagnosing the issue here. What is the bug? And then let's think about how we can fix the bug and how unknown container might play a role in that. We look down here, we see void drain first, okay? We're trying to drain the water from the first non-empty container. So let's say, just as a bit of an example, IntelliJ is gonna throw some errors, but that's fine. Let's say I have some containers like this. And let's say that this one has it's filled 4, 5, 0, 1, 2. And let's say the capacities are just like very large, so it's totally fine. Well, now we want to drain the water from the first non-empty container. So we say index 0. Okay, so now we're going to access containers index.drain. So we do the very first one. Well, how did the drain method work? If I remember correctly, the drain method was what we implemented in part A. We create an answer to whether or not the amount filled is greater than 0, then we set it to 0, then we return the answer. Okay. So 4. Well, 4 means that the answer is going to be true. So we're going to return true and set it to 0. So we're going to be returning true, which means that it's going to be while false, which means that we break out of the while loop, and that's it. So basically what we did is we set the first one to 0, right, as a result of calling drain. But everything else stays 5, 0, 1, 2. Well, it looks like it works, right? So what could the issue possibly be? Well, one thing that's pretty useful is if we try to think of edge cases. So what happens if everything is full? Well, if everything is full, then we're just going to get a repeat of what happened here, except instead of a 0, like let's say I say 6, it's just going to be 6 down here. Well, the other edge case that comes to mind is what happens if everything is 0? Well, in that case, the very first one is going to return false because there's nothing to empty. So then while true, so then we increment index by 1. So now index is 1. So this stays 0. Well, it's the same process. We're going to return false, and we're going to increment by 1. Return false and increment by 1. Return false and increment by 1. Return false, increment by 1. And then we're going to try again. So right here, this is index 4. But now we're going to be trying index 5 because we still incremented index. There's no check on how long the container list is, and that is the problem. If they're all empty, then this method is going to error because we're going to be trying something that is not in bounds for the array. Okay, so that I think is a little bit hard to realize unless you try out some examples, because just looking at the code, it looks to work, but when you realize that you can't just access anything in the index, it needs to be in bounds in the array, and it has to work no matter what, right? The question pretty clearly said that it should never error, and it should retain the functionality. Well, it seems like this is a pretty important edge case to check. It could be the case that we just haven't gotten around to filling any of the containers yet. Okay, so now we know what the error is, or what's going wrong with the drain first. So this line, this.containers equals the containers cons. Okay. Well, all that means is we're setting this instance member to the containers that we're passing in, the container list. So what was happening is we were trying to access something that was out of bounds, if you will. So how could unknown container play a role? I'll pause here for a second if you want to think about it. Well, unknown container might be the solution to our problem. If we have non-empty containers, we can put an unknown container, a non-empty, right? Or just a regular unknown container that we can drain. So that way we don't run into that problem. We break out of the while loop by forcibly returning true. And that effectively breaks open the whole problem. So this old way of doing it is wrong. So I'm just going to delete it. I forgot, I should not have deleted that. So let's go ahead and start putting our code in place. Well, we want to add an extra unknown container at the end. So I'm actually going to go ahead and implement unknown container first. You could do it the other way, actually, but it doesn't really matter at this point. But unknown container, what we're trying to do is basically forcibly return true. The issue was that we're returning false for all, and that keeps the while loop going. We want to break out, so we're going to return true. What are we going to return true on? The drain method. Okay, cool. So as is standard, we're going to be doing an override. So that makes sure that we're doing the override properly. If we have something wrong with the method signature or something like that, or we misspell, it'll call it out and say that's not an actual override. Like, okay, well, it's saying annotation is not allowed, but let me go ahead and start filling in the method. We want to basically change drain of this container. Then we're going to return true. Nice. And then in this, let's go ahead and similar to the previous question, because we were dealing with classes, we're going to extend container. Well, hold on. IntelliJ is clearly showing that there's an issue with that. And of course, in the exam, you would not have IntelliJ, so I'm not just going to hover over IntelliJ and give away the answer. Why might it be error? And I think that this is one of the things that might trip you up a little bit, is you can't just extend container because container is an abstract class. And in an abstract class, if you have an abstract method, you must override that too. So it's not just enough to change how drain is going to work. We need to change how pour is going to work. And the issue is, it's not possible. We can only add 4 lines of code to the unknown container class. Even if I deleted this app override, I would need at a minimum to declare the method signature, maybe just return 0, and then have a closing brace, which is another 3 lines, which means I'd have to have 6 lines, not 4. So it's actually that we're extending water bottle, not unknown container. All right, now let's go ahead to the final part of the problem where we need to start making our changes. So you want to basically put this unknown container at the very end of the list so that we can forcibly return true on the drain and break out of the while loop. So I'm going to set containers to a new array of containers. And I'm going to specify the length this time as being the length of const, the parameter, plus 1, because we need to add one more thing. Now we need to effectively transfer everything from const to this new container. Now, one question that might come up is, why am I copying everything? Why can't I just do const then increase it by 1? Well, arrays can't change size. It's not an array list, right? Lists can change size, you can add, you can remove, you can do all those fancy things, but you can't do that with an array. Array is easy to access, but it comes at that cost of you can't really change the size of it. So that's why we're going to go ahead and copy. So I'm a little old-fashioned. I like to write out my for loops because I can never remember the syntax for system.array copy. But if you want to do system.array copy, that's totally fine. I'll also write out the syntax for that too. So if I say for some int index equals 0, and then I put the index as being less than const.length, right? Because we're trying to copy everything from const to containers. We don't want to go over containers.length because then we're going to hit an out of bounds error with const. And then we're going to increment index. So let me go ahead and put that semicolon here. And then let's go ahead and copy everything. So I'll just do containers of index is going to equal const of index. Yep, IntelliJ actually notices that it's a manual array copy and wants me to change it to system.array copy. So I guess I can just go ahead and do that. That's the other way of doing it. And then finally, the one last thing I need to do is I need to go into containers and I need to then modify that very last item, right? Because what we've done is we've copied everything over from const into containers, but then there's that one last index that we need to do on const.length. And we need to set this to be a new unknown container. And you might be like, hey, there's no, could this error, could something else happen? Well, unknown container extends water bottle, and the water bottle has this. So we're totally fine. So that wraps up this whole question. Basically what we were doing is we were accounting for an error. And the error was that if I had a bunch of containers and they were all empty, well, I would just keep cycling through them because of this while loop. Drain would keep returning false because nothing was being drained, and then not false is true. So while true, right, we keep going until we hit a non-empty container. Well, you just keep going all the way. There's no check stopping you. So what our new containerless constructor does is this time, what we're going to do is we're going to add something to the end. So I'm going to copy into containers. I'm going to copy a bunch of these containers, and then I'm going to put in an unknown container. So that way I return 0 for all of these. And then when I get to the unknown container and I call drain, well, it's not doing anything, but it's going to return true, and we break out of the while loop, which means that the method ends, and there's no issue because we're not going to be trying to access the next element. One last thing that I want to mention here is why we even needed the unknown container. Like, unknown container doesn't really seem to be doing anything. It's like 4 lines. Maybe you didn't even have to use it at all. Maybe you can just use water bottle here, right? Like, just add another container. Well, there's a small issue with this, or I say small, but it's fairly large, and it all has to do with this hint. We need to make sure that the drain first method won't error, even if it is called many times. So if I was to put a new water bottle at the end, and for the sake of example, let's say I have 2 containers and then I have that water bottle. So say both of these containers are empty and the water bottle has capacity 1 and it's filled 1. Well, if I'm going to call drain on it, it's going to then go to 0 and we're not going to have any issues. Or actually, since the default, I think the default capacity was something like 16, we'll drain it down to 0. But when you call it one more time, we run into the same issue because now we're going to get true this first time. We're going to get true the second time, right? If I'm doing the not false, because we're looking for the first non-empty container. So we keep cycling through the while loop, and then we hit the water bottle. Well, the water bottle has the same issue that the containers had because now there's nothing in it. So we're going to go on to the next one. But that's where the error happens, right? We can't access the next one. There is no next one. And so then we get the out of bounds error, right? The pointer exception. So what we have to do is, independent of whatever happens with the drain, we're required to override it and forcibly return true to avoid this error because we need this to work even if drain first is called many times. That's exactly what this is showing. All in all, this was a fairly involved problem. And I think that it was pretty challenging for a couple of reasons. But what I'd encourage you to take away from this is sort of the approach that you have to go in with. It's very difficult to know what unknown container does from the beginning, or even to know what the error is here and how you need to modify it until you diagnose the issue with drain first. And the way that you do that is by doing examples. Specifically, you need to do examples of edge cases, right? Because even if you do a general example, like the very first example that I did, you'll notice that the code might work. So you have to think about how it might not work, right? In this case, maybe there's an issue with accessing the array index, right? That's out of bounds. And then you have to figure out how to deal with it because you're not allowed to modify this. The way that we do that is we're going to manually increase the size of the array and forcibly make it so that we break out of the while loop if everything is empty on the very last new unknown container. Okay, I hope this was helpful in understanding this question. And yeah, I think that wraps up midterm 1, question 7, part C, and we finished the entire problem.